Manisha Gupta from final year EXTC Engineering. Now I am here with a topic presentation on topic histogram equalization. Now first of all we need to know how many types of equalization techniques, and we can say how many types or how many techniques we are using for the enhancement processes. Correct? So the very first one is the linear and non-linear enhancement technique, and the second one is contrast stretching, and the third one is we can say image negative image, logarithmic transformation, power law transformation, and the last one, last but not the least, the histogram equalization technique. So what is exactly histogram technique equalization technique is? The histogram equalization technique is the most important and one of the most useful technique used in entire image processing. Now the second advantage of it is that we can use it on entire image or the piece or on the piece of image according to user's wish. The third most importance of this, it is used to improve the visual appearance of the image. Now let's take an example for that so that we can understand the concept of histogram equalization in more detail. So here is the example. This is in this you can see the different values in the table, correct? So what is that exactly? This is showing the various intensity level of the image, correct? Now you can see the maximum intensity. First of all, the very first step of solving this or applying histogram equalization technique is we have to convert this table into the matrix form. Okay, so we have formed the matrix of it. Now you can see in this matrix the maximum intensity value is 5, isn't it? Okay, now we have to choose the range. The range must be the power of 2, correct? Now let's take the example how it is implemented. Now let's take an example 2 raised to 1. What will be the answer? 2, correct? So will 3 or 4 and 5 will exist in the range between 0 to 2? No, correct? So it will remain as it is, correct? It won't be considered. Now let's take, so we will drop it. Now let's jump to the another number, that is 2 raised to 2. What will happen? If the answer will be 4, again 5 will remain, correct? So we will go for 2 raised to 3, that is equals to 8, correct? So it will occupy the complete number between 0 to 7, isn't it? Correct? Our maximum intensity also occupying can come in between this range, correct? So we will go for the 2 raised to 3 is equals to 8. Now we have to make the table for the pixel intensity and the number of pixels. Now our values is ranging between 0 to 7, isn't it? Now we have to see in a matrix for a single individual number that for how many times these numbers are occurring in a matrix. Let's take an example. In this matrix we can see there is no number between 0 to 2. Matlab 0, 1, 2 is not occurring in this matrix. So it will be remains 0. Correct? Now for 3, how many times 3 is occupying in this matrix? 1, 2, 3, 4, 5, 6, correct? So it will come 6, and 4 is coming for 14 times, so it will be 14 here, and 5 is for 5 times, so 5 will be there, and for 6 and 7 are not in the matrix, so it will be 0. Now we have to represent those number of intensities and the pixel intensities in a graphical representation. So what we'll be doing here, we will be putting number of pixels on a y-axis and the number of pixel intensity on a x-axis. Okay. Now we can see in the table for 0, 1, 2 it was 0, correct? So it will shown by 0 only. Now for 3 it was 6, correct? So it will represented by 6, and for 4 it was 14, for 5 it was 5, and 6, 7 for 6, 7 it was 0. Now we have to make the table for probability and cumulative probability, and again there is another column. I'll tell about you about that later on, and that is the last one is a round off table. Okay, so pixel intensity and number of times pixel has occurred in a matrix, that we have already done. Then the last part is that n is equals to 25. What is that? Just we have to sum it up. 6, 14 plus 5. Okay, so what will come? 25. Okay. Now how we find the probability? The general formula is what? Number of things divided by total number of things, correct? So we will be doing the same here. What will happen? This 0 divided by 25 will remain the 0. Same for these two, this row as well, correct? Now 6 divided by 25 will be 0.24. 14 divided by 25 will be 0.56. 5 divided by 0.2 will be 25 will be 0.2, and 0 divided by 25 will be 0. Okay. Now cumulative probability. So how we will find the cumulative probability? For the first row, what we do? We just copy the same number of the first row of the probability, correct? So we did the same 0. Then again for further we have to add this 0, the first row of the cumulative probability, to the second row of probability. So what will come? 0 plus 0 equals to 0. Then we will do the same procedure for the 0 plus 0, 0, 0 plus 0.24, 0.24, 0.24 plus 0.56, 0.8, 0.8 plus 0.2 will be 1, 1 plus 0, 1, 1 plus 0, 1. And now in this in another column, in next column, what we did, we have to multiply the maximum intensity value of the range to the cumulative probability. What does it mean? Let's see here. 0 into 7, 0, correct? 0.24 into 7, 1.68, 0.8 into 7, 5.6, 1 into 7, 7. Okay. Now rounding of the figure. 0 will be 0 as it is, correct? 1.68 will come out 2. If let's consider if it was 1.4, then what will be the answer? It will be 1 only. Okay. So what I am telling is, if any number after the decimal is 5 or more than 5, the maximum value will take place. Okay. Then we can see 5.6, it will be 6, and for 7 it will be 7 only. Okay. Now we have to. Now this round of figure is nothing but the new intensity level. Okay. So what we have to do here is old intensity level. We have to replace this old intensity level to the new intensity level. Okay. So what we'll be doing here, whatever the matrix or whatever the question we have taken, just we have to replace these values, these intensity values, to the new intensity value. Okay. Let's see. This is the column 1 consisting of 4, value 4, correct? And this is row 1 is consisting of value 4. Okay. Now in this column 1, the value is 4, 3, 3, 3, 4. Just remember it. Okay. And in center it was 5. Now let's see in a table. For value 4, what is the new intensity level? It is 6, correct? So what we'll be doing here, everywhere wherever the 4 value was present, 4 value were present in a matrix, we have to replace it by 6. Okay. So first column and the last column were 4, correct? So what we'll be doing here, we will be replacing it by 6. Okay. Now for 3, it is 2, correct? So wherever the 3 were there in a question, we have to replace it by 2. Okay. Now for 5, it is 7. So in center you can see this is 7. Okay. I hope you are getting it. Now we have to again plot the same histogram graphical representation. What we did in previous graphical representation, just we had calculated the number of times the number is appearing in a matrix. So again we have to do the same thing. Okay. Now we can see here this 2 is appearing in a matrix for 6 times, correct? 1, 2, 3, 4, 5, 6. So we can show here by the graphical representation by 6. Okay. Now this 6 is coming for 14 times, 5, 5, 1, 2, 3, 4. Okay. Then 10 plus 4, 14. So we have represented here 14, correct? And 7 is coming for the 5 times, correct? So 7 is there, and rest are not in a matrix, so rest are the zeros. Okay. Now thank you for the watching and listening carefully. Thank you.